In this example, we are going to look at the composite functions involving y equals ln absolute of x and trigonometric functions. For part A, we have y equals ln absolute of cosine x. We are going to introduce the variable let inner function be u. Outer function will be y equals ln absolute of u. U is not equal to 0. Next step, we are going to calculate the derivative of each function. du dx is equal to negative sine x, and then dy du. By using the first formula here, we will have 1 over u. By using the chain rule, we will have dy dx equals dy du times du dx. We will have 1 over u times negative sine x. Then u will be replaced by cosine x. Now we will have negative sine x put on the top, and denominator is cosine x. And this one, by using the ratio, we know it is equal to negative tangent x. Y equals ln absolute of sec x. This is very similar to part 1. If we are familiar with the derivative of sec x, then we can use the above idea. Let u be sec x, outer function will be ln absolute of u. Calculate du dx, so sec x here, and its derivative is positive, and it's sec x times tangent x. dy du is the same to the above question. We are going to use the chain rule to get the final answer. The final answer is tangent x. But if you don't know the derivative of sec x, then we are going to use the second idea to get the derivative of the whole function. Try to find a relationship between these two functions in part A and B. We know sec x is the reciprocal of cosine x. Then the absolute sign can be separated for absolute 1 and absolute of cosine x. Then absolute of 1 is just 1. Now after that, we are going to convert this fraction to the power form. It means it's power negative 1. Then use the property of natural log. We can put negative 1 to front, becomes the coefficient. It's negative ln absolute of cosine x. Therefore, we are going to write it in this way. The derivative of ln absolute of sec x is equal to the derivative of negative ln absolute of cosine x. And then for this function, negative, we can put it to front. And this one, by using the result of part A, it is negative tangent x. Then negative become positive. The final result is still tangent x. Based on the results of part A and part B, we will obtain an important result, which is the integral of tangent x is equal to ln absolute of sec x plus c, or negative ln absolute of cosine x plus c. The first form is more commonly used in our course. Now let's move on to part C. Here we have y equals ln absolute of sine x. The inner function is sine x. We are going to let this one be u. The outer function y equals ln absolute of u, and u is not equal to 0. Similarly, we are going to calculate the derivative of each function. Du dx is equal to cosine x, and dy du. Using the first formula, we have 1 over u. After that, based on the chain rule, we will have dy dx equals dy du times du dx. The result is cosine x over sine x. This ratio is equal to cot x. Based on this result, we will get another formula. If we integrate cot x, then the result will be ln absolute of sine x plus c. Similarly, the reciprocal of sine x is cosec x. Therefore, we will get the result in another form, negative ln absolute of cosec x plus c. Similarly, this form is more commonly used in our course.